The 19th one that has been inspired from current electricity and more precisely experimental one. Now this is another piece of advice I would like to give to all aspirant, that any given topic wherever experiment and measurement is associated, take extra care of those things. There is a high degree of probability of question raining into from those topics. So here it says, in the given circuit, an ideal voltmeter connected across 10 ohm resistance. So here is that ideal voltmeter. The resistance would be infinite. The ideal voltmeter reads 2 volt, and we need to calculate the internal resistance R of each cell. And there are 2 cells which are connected in series. So let's see the infinite resistance, quite obviously, that's an open circuit. So when I calculate the net resistance of this parallel, 15 and 10, that will give me 6 ohm. This is 6, this is 2, this is 2R. So now, so easily you can calculate the current. The current is 3 volt divided by, what are the resistances? 6 plus 2, 8, 8 plus 2R, that's the net current. And that current multiplied by the net resistance, which is 6, that now will be equals to 2 volt. So that's a part, and you calculate resistance, the internal resistance, that will be 0.5 ohm. That's so visibly clear. Option number 1 would be the correct one. Should we move to question number 20? Yes, please, let's do. Question number 20, from gravitation. And again, a very simple, don't go into the width of the question. It is indeed a very simple one, straight formula based. The value of acceleration due to gravity Earth's surface is this much. The altitude above its surface at which gravity decreases to 4.9 is close to. So I need to calculate that height where gravity becomes half. And that will be G dash equals to G into 1 plus H by R raised to the power minus 2. And the radius 6400 kilometer, which is a common, and I think one of the most common value. You put those things, you would get option number 4 as the correct option. Here the altitude has been asked, not the distance from the center. So be careful, the height measured from the surface, which is the altitude, and that is option number 4. Fine, we have completed 2/3 of the question. Now let's go to the last 1/3, 21st question. Let's move. Question number 21, that has been put from properties of matter, and more specifically surface tension, more specifically the capillary effect. Now there are 2 liquids, one is water, other is mercury. The ratio of surface tension has been given. Now you may represent it by S or you may represent it by T on whatsoever convention that you have been following. We're not strict on that. The ratio of the densities has also been given, and the contact angle, quite obviously for mercury 135 degree, for water 0 degree, these are almost standard value. It is observed that mercury gets depressed by an amount H in a capillary tube of radius R1. So this is the tube radius. And likewise, water rises by the same amount in capillary tube of radius R2. So we need to calculate the ratio R1 upon R2. So what we do is that, say, the height of Sn is quite obviously 2t cos theta by rho gr. That's the radius of the tube. Now let's see. Quite obviously, what you can see is that this is directly proportional to t cos theta divided by rho times r. And we need to calculate the ratio of R1 is to R2 with the given fact the height of ascent and the height of descent. Of course, when it comes to descent, we need to say the magnitude, that's equal. So you put it, that's very, very straightforward. You get option number 4 as the correct option. That was fine. Now let's move to the next question.